Hello, in this video I'm going to solve the following gold level problem on the topic of definite integrals. Evaluate the following integral. Integral from 3 to 5 square root of x plus 2 times the square root of 2x minus 4 plus the square root of x minus 2 times square root of 2x minus 4 dx. Pause the video at this point and give it a try. If you do the calculations correctly, the answer to the problem will be 4 square root of 3 minus 2 square root of 2 over 3. I will use the method of substitution to solve this. The variable that I introduce u, I define it in this form. I will take it to be square root of 2x minus 4. Then I raise both sides to power 2. And then I differentiate both sides. The left hand side becomes 2u du. The right hand side becomes 2 dx. When I divide by 2, dx becomes u du. I will need it for the future, so let me keep it here, okay? Now I also need to know what are the new limits, because the old variable x, according to the problem, goes from 3 to 5. This implies that u goes from, if I want to find the lower limit for u, I will take the lower limit for x and put it here. 2 times 3, 6 minus 4, 2, square root of 2. So the lower limit will be square root of 2. I will do something similar for the upper limit. I will take 5 and put it here. 2 times 5, 10 minus 4, 6. So upper limit becomes the square root of 6. Okay? One thing that I need here, I also need to know x in terms of u, because you know that if you do the method of substitution, you have to eliminate all old variables in favor of the new variable. For dx, I do not have any problems. I have it here. For square root of 2 minus x here and there, I do not have any problems. That is just simply u. So I need to get rid of these two x's in favor of the new variable. But if you don't mind, as you see, they are completely similar, except that this is plus, this is minus, so let me do both of them together. But in order to do that, I need to know what x is, so I can calculate x in terms of u from here. So this means that u squared plus 4 is 2x, and then I divide everything by 2, x becomes 1/2 u squared, and then plus 2. Okay, so these two integrals that appear in my integrand now can be written as x plus or minus 2 square root of 2x minus 4. So this becomes a square root of, instead of x, I can put 1/2 u squared plus 2. I'm using this for x. And then I have either plus or minus 2 times the square root of 2x minus 4, which is just u. Now what I will do, under the square root, I will factor a 1/2 out. The first term becomes u squared, the last term becomes plus or minus 4u, and the middle term becomes plus 4. Let us double check. So here I multiply 1/2 here, it gives me the first term. I multiply the 1/2 here, plus or minus 2u, which is the last term, and multiply 1/2 here, it gives me 2. So what I have done is right, but this is just a squaring rule, so I can write it as square root of 1/2, and then I have u either plus or minus 2 to the power of 2, and now this becomes 1 over square root of 2, but the square root of u plus or minus 2 to power 2 is not simply u plus or minus 2. Be careful, you have to put absolute value of u plus or minus 2. Okay, very simple now. So what I can do, if you don't mind, let me call the name of my integral I. So then I would write I is equal to, instead of this expression, I write this expression with the plus sign. Instead of this expression, I write this expression with the minus sign. And you see both of them share this factor, and that is factor, I pull it out, and because it is a constant, I can bring it out from my integral. An integral from be careful, not from 3 to 5, the new limits are these. So I have to run it from square root of 2 up to square root of 6. The first one becomes absolute value of u plus 2. The next one becomes absolute value of u minus 2. Okay, but remember, at the end I have to multiply by dx, which I found it to be u du. So this becomes u du. Now what I want to do, I want to break my integral into two parts. So what I will do, I will multiply u here, and I will multiply u here. Then I have the sum of two functions. The integral of the sum of two functions can be written as the sum of the integrals of the individual functions. Okay, but this overall constant is for both, so let me copy and paste it here and open a pair of brackets here. Integral from square root of 2 to a square root of 6, and then I have absolute value of u plus 2 multiplied by that u du, plus integral from square root of 2 to square root of 6, absolute value of u minus 2 times u du. Okay, the next thing that I have to do whenever I am dealing with an integral in which the integrand carries absolute value, I have to get rid of the absolute value first. To get rid of the absolute value, you know that you have to be certain about the sign, positiveness and negativeness, of the expression within the absolute value sign. If you are certain that expression within the absolute value sign is positive, you just remove it, remove the absolute value sign. But if you are certain that the expression within the absolute value sign is negative, you can remove the absolute value, but you have to be careful to multiply the whole expression by an overall minus sign. So here, I don't need these absolute values. Why? Because I know that u is somewhere between the square root of 2, square root of 6. So this means u is positive. When u is positive and I add 2 units to it, definitely it becomes positive. So if you ask me what is the sign of this expression within this interval, definitely positive. So this can simply removed and it can be replaced by a pair of brackets, and then u will be multiplied here and there. So remember, I will write it as u squared plus 2u later. But here I have a little bit of problem, because a square root of 2 is a number less than 2, and a square root of 6 is a number greater than 2. And this is crucial for this, because if u is less than 2, u minus 2 is negative, and if u is greater than 2, u minus 2 is positive. So this means that I cannot remove this absolute value sign. So this is also a standard trick. You have to break your integration interval to two pieces, so that on one piece u minus 2 is always negative, so you can safely remove the absolute value sign and multiply the expression by minus sign. And on the other interval it is always positive, you can safely remove that. And it is easy to see that that threshold is number 2. So I will break this interval from square root of 2 to 2, and then from 2 to a square root of 6. Okay, so let us do that. So I will copy and paste 1 over square root of 2. As I told you, the first one I can simply write it as this expression u squared plus 2u du. And the next one, I will go from square root of 2 to 2. But be careful, when you go from square root of 2 to 2, u minus 2 is negative, so you take this off, but the price is to multiply it by a minus sign, and then you have also a u here, so it becomes 2u minus u squared. So that is what you have to write here. So it becomes 2u minus u squared du, and then from 2 to a square root of 6, but in this case u is always greater than 2, so this is positive. So I just remove it and write u minus 2 in pair of brackets, and then multiply u here and there, so it becomes u squared minus 2u. But I hope that you can agree with me that all these integrals are extremely elementary ones to calculate. So let me do them a little bit fast here. Okay, so I will copy and paste if I can fit everything here. Let me do my best. So a primitive function for this is 1/3 u cubed, and a primitive function for this is 1/2 u squared. This 1/2 cancelled that too, so it is very simple. It becomes 1/3 u cubed plus u squared. I have to run it from square root of 2 to square root of 6. The next one more or less similar, so it becomes u squared minus 1/3 u cubed, but this time I have to run it from square root of 2 to 2. And finally the last one, again 1/3 u cubed minus u squared, and then I have to run it from 2 to square root of 6. Okay, and then we know what to do. Yes, so I copy and paste this factor, and let me split every one of them into two parts. Okay, the first thing, I have to replace this u and that u with the square root of 6. But you know that square root of 6 to power 3 is simply 6 square root of 6, but this 6 and this 1/3 will become 2. So it becomes 2 square root of 6 plus 6. And then I put the square root of 2 there. So it becomes 2/3 square root of 2 plus 2. And then plus the next one similar. So let me do it quickly. So this becomes 4 minus 8/3. But if I calculate that, it becomes 4/3. And I put 2 there, a square root of 2 there. So it becomes 2 minus 2/3 square root of 2. And then finally, I will put the square root of 6. For the same reason, it becomes this number, minus 6. And then I put 2. So it becomes 8/3 minus 4, which will be minus 4/3. Okay, and then every time I have to write the number above minus the number below. So let me do that. So this becomes 1 square root of 2, the number above minus the number below. Yes, the next one, the number above minus the number below, and the number above minus the number below, which will be minus 4/3. So that will be my answer. But let me simplify it as much as I can. So you see I have 2 square root of 6 here, another 2 square root of 6 here. So it becomes 4 square root of 6. And let me also, let me write the answer here. So let me open a little bit of a space here. So I will have, let me write also with different colors. So this will be this, and then I will have 4 square root of 6. What about other numbers? This one you see, and that one are totally gone. One of them is positive, the other one is negative. And then let me calculate the numbers. So I have positive 6, minus 2 is 4, minus 2 is 2, minus 6 is minus 4. So I have minus 4, and then I have 4/3 plus 4/3 is plus 8/3. So it becomes minus 4/3 if I take the common denominator. So it becomes minus 4/3. And then I multiply 1 square root of 2 in. So it becomes this number, minus 4/3 square root of 2. So square root of 6 divided by square root of 2, simply square root of 3. And the next one, I multiply the numerator and denominator by square root of 2. So the numerator becomes 4 square root of 2. The denominator simply becomes 3 times 2. And then 2 and 4 are cancelled. And finally, I get the answer which I am supposed to get. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.